In this video, I'll be talking about the two different types of covalent bonds. So, covalent bonding. The simplest definition for a covalent bond is bonds between non-metals. And that is two. But you also need to know that in a covalent bond there will always be sharing of electrons. Now, I mentioned there are two different types of covalent bonds, and that comes into place when you consider that sharing of electrons. In one of the cases, there is equal sharing, and in the other case, there is equal and unequal sharing. So we'll consider each separately. So first of all, let's view our periodic table. So when you consider a covalent bond, as I said before, it's usually between the non-metals. So we'll have this section right here, and hydrogen. Now, when we think of electronegativity, again, E dot N, if you're having a bond between two nonmetals, we said that the electronegativity here is pretty high, considering fluorine is the highest, is the one with the highest electronegativity, and it goes up like this. That's our trend, and to the right, increasing. That's increasing. So when you have a bond with something like fluorine, let me change the color. Fluorine and oxygen, the difference will not be high because both electronegativities will be really high. So it's good to establish a barrier between something you call an ionic bond and a covalent bond. And we said that our ionic bond will be anything that has a difference that is equal or above 2. So it's safe to say that something that has less than 2 will then be considered covalent. So this is ionic. So now we have our base to better explain covalent bonds. So we have two different types of covalent bonds. The first type I'm going to talk about is called a non-polar covalent bond. And this is sometimes called a pure covalent bond too. It's the same. So when you have a non-polar covalent bond, there will be equal sharing of electrons. And our electronegativity difference will be very close to 0. If not 0, of course. Actually, I'm sorry. The electronegativity difference is always 0. So not close to 0, it's always 0. And if you think about it, the only way you can get an electronegativity difference of 0, exactly 0, not close to 0, sorry for that, is when you have a bond between two of the same molecules. And that occurs in our diatomic elements, or better known as Brinkelhoffs. Br, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. I mean, because if you remember well, these elements exist in nature as Br2, I2, N2, Cl2, H2O2, and F2. So something that goes like this, F, there's sharing, so you can actually write a line. F will be 4.0, that's its electronegativity, and 4.0. So the difference will be equal to 0. So this forms F2. So whenever you see a diatomic element that is part of our Brinkelhoffs, then the electronegativity difference will be equal to 0, and you can call this a non-polar covalent bond. Now the other type of bond, of covalent bond, is called the polar covalent bond. And this type of bond there will be sharing because it's a covalent bond. In all covalent bonds there will be sharing, but the sharing is unequal. So one of the elements will be pulling out more electrons. It will have more electrons. And these polar covalent bonds occur between nonmetals and or metalloids. So you could have two nonmetals together, a nonmetal and a metalloid, or two metalloids. But you will probably never see two metalloids bond together. So as I said, it's unequal sharing of electrons. So let's say this is our molecule A, and this is our molecule B, or atom B. Now there will be some sharing there, but just to picture how the electrons flow, I'll make this like a kind of circle thing. So there is a force there. There's a bond, and one of the elements will pull more electrons than the other one. So one of them will be more negative, and you call that a partially negative element. And so therefore, this one will have less electrons. Something that is electron deficient is positive, so it will be delta plus. And you can just draw this. This is electrons. Just think this drawing is electrons. So it'll have more electrons around it. Well, if you remember from what I said before, the difference in electronegativity between for something that we call ionic is more or equal to 2. If something has an electronegativity of 0, then it's called nonpolar covalent. And then the only thing that remains is just delta En is equal to 0.01 to 1.99. So if something is higher than 0 and smaller than 2, it's called a polar covalent bond. And just to give you a sense of how it will look, we said that our ionic one will be like, we have a cation here, it's usually very small. I'll talk about the size of ions in the following videos. Then we have a bigger negative anion, and there will be a force between them, electrostatic attraction. No sharing though, so I'll do it dash lines, because there's electrostatic attraction. It's a bond, but there's no sharing of electrons. Then when we think of nonpolar covalent bonds, we have something like hydrogen and hydrogen. So you could just, using the same diagram we used last time, like this thing, then you could just think of a nonpolar covalent bond as something that is equal. So it will have an atom here, an atom here, and everything is shared between them. So there's electrons everywhere. That drawing again, that scribbling thing is electrons. Well, finally, we had our polar covalent bonds. There's one atom here and one atom here. And we said that something will pull more electrons than the other element. So it will be considered as something that's delta negative. Therefore, the other one is delta positive. And this side will have all the electrons, pretty much. And this will make more sense when you start drawing Lloyd structures, because let's say if you think of something like HCl, you have a covalent bond there, they're sharing, but the chlorine will want more electrons than the hydrogen, so this can be considered as something delta negative. Those dots there are electron pairs. It's 6 electrons there. And then this hydrogen will be delta positive. Just because the chlorine has a higher electronegativity, it'll want to pull out more electrons. So it'll be considered as partially negative. Well, those are covalent bonds, and I made a quick review on ionic. So there is only one more type of bond left, that's metallic bonds. I'll talk about that in the next video. And if you have any questions, just email. We'll be glad to answer. And if the video was helpful, like it and share it with your friends.